Testing. All right, good evening. Can you guys hear me?
Yes.
Yeah.
All right, welcome back to another week. Of course, there's been a change in plans, at least from my side. I also teach science and social studies, and they finish class on the 16th. But for some strange reason, you guys actually finish next week. So I had it in my mind that you guys finish the same time until I rechecked the dates, and I saw that you actually finish next week. And let me just do a double check just so I don't say something and I'm wrong about that. But yeah, that's what it looks like. And so that changes plans. I was hoping to, the last week, I was hoping to do a review, but instead it looks like our last week is next week.
Okay.
And I'm just double checking just to make sure. And yeah, that's correct. So actually we finish on December 10th. That's next week, Thursday. So slight change in plans there. We won't actually be continuing to the last week there. But the other plans are still there. If you are intending to take a test this month, you may remember the tests were, not tests rather, but the spaces were all sold out in a sense. And that's mainly because of COVID-19 restrictions. I forget the limitations, but they can't fit the same amount of students. So December just happened to be one of those months that just people from outside of the school also signed up to take the test there. And so remember, I had said to you guys that on December 15th, they will have a special day to try to get as many Fontana students in there as possible.
Yeah.
The day for that registration will be on December 14th.
Okay.
I'm not sure of the exact time, but I believe you guys should have received an email from the school regarding that. Did you guys get it?
No, I haven't.
No, I did not get anything.
I haven't.
Not yet.
You said you did?
No, sir.
No.
Okay.
No.
All right. So some of, actually, yeah, you know why? It's because you guys are registered as Math Foundations. Yeah, so I'll try to get the school to send that email to you guys, as you actually have moved faster than my other class. But anyway, it's going to be on the 14th of December. Let me just write this down real fast. All right, so that's going to be on the 14th of December. And that's the date that the registration will open up if you are trying to take it. Now, more than likely, it will not, they don't have enough room for even all the Fontana students. So that's going to be kind of a mad rush as well. So there's no guarantee, sadly, whether or not you'll be able to get on there. I'm not sure what time exactly it's going to open, but as soon as the registration is opened up, you'll want to register. And so I'm going to try to see if I can find the exact time, as there are going to be other teachers and their students trying to make sure their students can get registered for that day. So,
Mr. Ray,
yes.
this is Salvador. Mr. Ray, I was there on Monday and I was talking to a lady over there in the front office because I had to take an assessment test to register again. And I was telling her that if I could do it like Sunday night around 12 a.m., obviously it was a 14 now. And she kept on saying that the lady that opened up the registration, she wasn't able to do it until she was there at school, and she couldn't do it until 8 a.m. But obviously you have to confirm that. But because I kept on going back to saying, well, can I register like late that night, Sunday night? And she kept on saying, you can't, not until 8 a.m. when she's in here to open up the registration.
Okay, so it sounds like that would be 8 a.m. So if that's the case, I would say if you're available at that time at 8 a.m., try to register. But I believe as Latavia, you had told me you could take the test online now. They actually have that option?
Yes, sir.
Yes, so I'm assuming because of COVID-19, they've allowed for that. And if I remember, you said you have to keep your computer camera on.
Yes, you have
Yeah.
to show them your back, front, left, and side, and where your computer's position and everything. And once they give you the go ahead, you can start.
Oh, wow.
Hmm.
So they'll be watching you intently.
Oh, yes.
Mr. Ray, let
You
me
can't
ask.
see them, but they can see you.
Yeah, there's gonna be somewhere there like this, just watching you.
Right. Yeah.
Yeah.
Mr. Ray, are we going to really start in Fontanado School, or we do it online?
Well, it's they prefer that you go through them, but I mean, they can't really, you know, you are adults, but they do prefer that you go through them. But if you're trying to get it done and there's an opportunity to do it another way, you know,
Yeah.
they
but
they do get the information because they're a testing site and you're enrolled in the school, and you can always inform them to let them know. But they do like to monitor the students to see who passed and whatnot.
And I think with the GED also, they can send your results to their school that you're going to, because when I signed up, I had an option.
Right,
That right.
right, and that's where they could also get that information as well. So, you know, if you really wanted to take it this month and the 15th doesn't work, that's always an option, and you could just let the school know via them sending the grades there.
Right.
All right, so just a welcome again to everyone. I got your names down as we were talking, so just welcome Salvador and George, Jacob, Dorcas, Clemente, William, Latavia, Norma, Gennaro, and Marisol. And I'm just doing that because
Hi,
we have
Mr.
a
Ray.
shorter time. Good day. We have a shorter time than originally planned. Up until yesterday, I was thinking it was the 16th. And it's kind of strange. Like I said, my other classes, I teach 3 other classes, 2 science classes and 1 social studies, and they all end on the 16th, strangely or not. So you guys don't, you end on the 10th. So that's the date. So unfortunately, we're ending next week. And so we want to try to get as much done today as possible, since I had planned it differently. So the first thing I'll ask, and it's like I said, it's always good to know something well. It's better to know 80% of the information completely, like you know 100% of that 80%, than to cover 100% of the information and you only know about 30%. So it's always better to have quality over quantity. And so because we want that quality, any questions from the workbook?
Yes, Mr. Ray.
Yes, Mr. Ray.
Let me start with
All right, so I have 2 people with questions, and go ahead, George.
Yeah.
I had heard you first.
let me start with page 85 workbook. The problem is number 23. We did it
Okay,
on that day.
that was oh no, we're not gonna.
We've not reached that point.
Well, I wasn't gonna go over that, but I did briefly go over that with you guys. You may remember I said if all else fails, substitute. Do you guys remember me saying that?
Yes, sir.
Okay.
Yeah, so I'll do this one just because, you know, this could pop up and this could be your, you know, maybe to help you pass. With this one, I'm not going to show you how to solve it. Just remember I said if all else fails, you don't know what to do, then what you want to do is just substitute. So there is a way to solve that, but we just don't have time to really get into it. So most of the questions that are going to come up like this, you could solve them just by substituting the values in there. That's basically what we're doing today. So all you need to do is substitute each one in, x for y, x for x, sorry, and y for y. And if it's true for both of them, then that's the correct answer. And I'm just going to peek in the back. This is unit 3, because I want to optimize time because I don't want to spend too much time on this. Is unit 3, lesson 7. And just want to make sure we do this really fast. So unit 3, lesson 7. And this is number 23, I think. So it says the answer should be A. All right, good. That means we don't have to do all of them. So I'll just do A and B. The answer should be A. When you get to a question that looks difficult, but you see an X and Y, remember, if all else fails, substitute. So this solution, this system says 7x plus 2y is equal to negative 11. And then we have 3x plus 5y equals to 16. Remember, these are x's and y's. And we learned about what's called ordered pairs, x, y, right? And they give you that. For A, they give you the first x, y, that's negative 3 and 5. And so, although you may not know how to solve it, you should know how to substitute. And if all else fails, you're not sure what to do, but you can see that you can substitute something in there, substitute. All right, so we're going to go ahead and substitute A in there, and I'm going to change the color to blue. Remember again, trying to move everything around that we had here. And I see a chat message. All right, so an answer ready. All right, so if we use 3, negative 3 and 5, as I said, the answer was, you see that if I substitute for x, wherever I see x, put negative 3, and wherever I see y, put 5. And we want to see if it is true for both of the equations. So this represents the first equation. If I multiply these, 7 times negative 3 is negative 21. 2 times 5 is 10. On the left side, negative 21 plus 10 is negative 11. So for the first equation, that works. And it has to work for both. So then I try the second one. If that point works for the second one as well, then that's the answer, A. And so we do that. We have 3 times negative 3 plus 5 times 5 equals to negative 11. That becomes negative 9. 5 times 5 is 25. So I have negative 11 there. That should say 16. And there. All right. So if this equals to 16, then that's the solution. And negative 5 plus 25 is indeed 16. And since that worked for both of them, that means A is the correct one. And that could work for anyone. Number 22, that could work for number 17. You might remember I had said something like that before. I said you could just almost a lot of the equations that you have, if you just substitute, you could find the answer. Just to give you another example where that would work, turn to page 117. If you look at page 16 on 117, you could do the same thing. If you don't know what to do, you could substitute to see which ones work. And whichever ones work means that's the correct answer. Now, my suggestion would be to flag the questions. If you're not sure what flagging is, if you read the instructions, they give you time to read the instructions before starting. It talks about how you could flag a question. So basically, you click this button and it flags it for you. So before you finish, it will show you that you have flagged it and you want to come back to it. So if you get any of those weird ones, flag them, finish everything you know, and then go back to each flag one. And if it's one like this, then just practice substituting each one. And whichever one works is the correct answer. Does that make sense?
Yes.
Yeah.
Right, so the same thing could happen here. I already had said that it would be very difficult to get to any of these, but they don't ask you that many questions that come from this section. So the reality is, based off of what you know, as long as you know how to do it and replicate it, you have enough information to pass the test. And not just pass it, but pass it with a good score. So that's just an example where you could just substitute values in. All right, I do want to try to finish the other stuff, and hopefully next week we can try to touch on some more of those ones where you could just substitute. Before I do that, one more example where you can substitute values in. If you turn to page 91, we won't be able to get to this where I can really teach it to you, but if you turn to page 91 and you look at number 7, the same thing there. You could just substitute values in for that one. So wherever you see like x equals or y equals to a specific number, or the ordered pair x, y, you could substitute the values in. Whichever one works would be the correct answer. Now, like I said, don't feel bad if we don't get to these. They don't ask a lot of questions that come from these ones. Most of the questions are how to solve equations, how to do tables, how to graph, how to interpret the graphs, the points, all of that stuff. It's not too much of the more difficult stuff. And so if we don't finish it, it won't cause you to fail, basically. All right, so hopefully that helps, George, and whoever else might have had a question. Any other questions on the other homework that we were supposed to do?
I have one, Mr. Ray. On, what is it, page 98 to 101, question number 10.
Okay, that's the exact same question somebody had this morning. That if point X -6.
I think, what is that, page 98?
98 or 99, I'm guessing, because you said 98
Yeah,
too.
99, yeah.
Yeah, okay, yeah. Someone had that question today, and so let's go over that one. So this one says, if point X -6 were translated 3 units down, what would be the new coordinates? All right, so first of all, you just want to get an idea of what X -6 is. Remember, this is the X-axis.
Which question? Which question? Question number
Page-
what? Number
Page
8.
99, number 10 in the workbook.
Okay.
All right, so where was I? So yeah, they had the point X -6. So remember, on the X-axis, we have the point 1, 2, 3, 4, 5, 6, and over here it's -1, -2, -3, -4, -5, etc. On the Y-axis, on the up side, that's 1, +1, 2, 3, 4, 5, 6, and 0, remember, is in the middle, and then down, -1, -2, -3, -4, etc. -6, -7. All right, so this thing says, if the point X -6 were translated. So that X -6 means I don't know what the X value is, but I do know that that point is somewhere down on the bottom, somewhere here. It could be anywhere. Any of these points could represent X -6 because I don't know what the X value is, but I do know that it's on the Y level -6, if that makes sense.
Yeah.
So it could be any point on that line, right? We don't know what the X is. To give you an example, this point here that I'm making really big, that's the point 5, -6. This point here, which I'm making big, that's the point -2, -6. And so each of these could be one of those things that we're looking for, X -6. We don't know which one, but it's somewhere on that line. Does that make sense?
Yes.
All right, so then it says, if that point were to be translated 3 units down, so it doesn't matter which one, you just want to get an idea that it's somewhere on that plane, it's somewhere over here, somewhere like 6 feet below water. You could think of that, but you don't know where. Is it underneath the boat? All I know is swimming 6 meters under the boat. We don't know for sure, right? That's all that's basically saying. But then it says, what happens if it's translated 3 units down? So imagine it's something swimming and it goes 3 units down. Then where would that point be now?
-9.
Minus 9.
-9.
-9, right? That thing's gonna drop. Think of it as a shark or something. You're trying to hunt for Jaws, and Jaws swims down. And as Jaws swims 3 more units down, then he'll be at -9. Now that's how you look at it graphically. Sometimes you may not have a graph, and that's where you could just put here -3. The -3 just indicates you're going down. And so that means your new one would be X -9, because -6 minus 3 is -9. Now the way to also remember it is that on the, if I put here X and Y, the X-axis goes left and right. And on the right side, that represents positive values, and going to the left represents going on the negative direction. For the Y values, they represent going up and down. And up represents going positive and down negative. No different than the diagram I don't know if you guys were here for integers, but when we went over integers, I drew like an ocean. I had a scuba diver under the water. I had a mountain above and birds flying. And I was trying to show you that if I go in one direction, represents positive. If I go the opposite direction, negative. And then when I do the up and down, going up is positive, going down is negative. And so this would be our answer here, because we went down 3 points on the Y-axis, if that makes sense.
Yes, and the y and the x remains the same. That's why it says x minus 9. Okay, I got
Right,
it. Sir.
because we don't know what the x is. So he could have went down anywhere. So let's say we're up here hunting the shark. Like, where is this shark to? We just know, we could tell it's 6 meters below, but we don't know exactly where on the x-axis. So that x just remains blank. But we know it's swimming somewhere around there, and then we get an indication it goes 3 feet down. That's like a way you could visualize what that means.
Got it.
All right. Okay, so we're gonna do some questions from here. Any other questions from this section? All right, if not, I'm just gonna start at number 1, and just bear with me. I wanna open up something that can help visually. Meant to have it open earlier. And where is it? Shortcuts. And okay, so that would be opening on the side. All right, so we're going to start at number 1. And for number 1, if you look at that page on the side, it says, what are the coordinates of point G? And I'm just trying to switch the screen real fast. It'd be easier than trying to draw a coordinate grid every single time. There we go. All right. So number 1 says, what are the coordinates of point G? And so
I think it will be 3
It's
on the horizontal points.
3 minus
Is it 3
4.
minus 3?
okay, I heard a good bit of answers and a good bit that were very close to being correct and correct.
Positive 3
3,
and negative 3.
3, negative 3.
Yeah, I'm hearing a bunch of right answers now. 3, negative 3 is correct. On the x-axis, it's touching 3. Remember, that's how you start. So it's x, y. So on the x-axis, we're at 3. And then on the y-axis at negative 3. So that makes it 3, negative 3, as was correctly stated. And which choice selection is that?
That's D.
B.
D. All right, any questions with number 1?
Mr. Ray, let me ask something. Okay, we have to start from left to right, no so? Yeah,
Wait,
because
Oops.
I mean
sorry.
the point of for the coordinate grid. I believe we need to start from left to right, or let me see, from horizontal point. Let's take the horizontal first before vertical.
Yeah, we start on the x-axis, the horizontal. So we say 3 first. That's what we write first, and then we write where it's located on the y. So the point is 3, negative 3.
Yeah, negative 3. Then at the top of the point it should be.
Yeah, you're working your way up to where the x-axis is, and then across to the y.
Okay.
Up or down, depending where the point is. All right, let's try number 2. Number 2 said, excuse me. Number 2 says, if circle G and its center were translated up 1 unit and left 2 units, what would be the next or new location of point G? So once again, up 1 unit and to the left 2 units.
Positive 1, negative
1
2.
minus 2.
Okay, that was a kind of unanimous there. Positive 1, negative 2, and I'll just do the actions again. If you went up 1 unit and then to the left 1, 2 units, you will see that it's now at positive 1, negative 2, as was correctly stated. And which choice selection is that?
A.
That's
A.
A. All right, how about number 3? Which of the following ordered pairs identifies the location of point D?
A.
Okay, I heard A very loud and strong there, and that is correct. Any questions regarding that one?
Nope.
Okay.
Did I hear a yes?
No questions, Mr. Ray.
All right, perfect. The x-axis is 2, y-axis is 5. How about number 4? Points A, B, and C.
B.
Okay, I didn't get to finish, but points A, B, and C mark 3 corners of a square. All right, and then they say, what is the 4th corner needed? And you said B, negative 5, negative 1. So I heard negative 5, negative 1 as an answer.
No.
No,
Oh,
it's
David.
1,
Yes,
negative
David.
5.
Oh, sorry, he
1,
said
5.
Yeah, so he agreed with that. D was the question. D is in David, not B is in boy. And both of you are correct. That one there would also be correct. 1, -5 would complete that square. Any questions so far?
Nope.
All right, how about 5? Points C, F, and E mark the corners of a rectangle. What is the location of the 4th corner needed to complete the rectangle?
D.
That's
I got it.
-1, -2,
Okay,
which is D.
I heard D and I heard -1, -2, which is also D. That is correct as well. If you were to sketch out a rectangle, you would have to notice that point would be at -1, -2 to make a proper rectangle. And a rectangle, remember, has 90-degree corners or right angles, we call them. And so you can't have a crooked rectangle. All right, number 6. What is the new location of point D? Look where D is, the same D we had earlier. What was that, 2, 5? So what is the new location of point D if it translates 5 units down and 2 units to the right?
+4, +0, 0.
A.
I heard +4, 0.
Uh-huh.
Anyone else? What's the
Hey.
confirm?
Yes, that's
Yes.
yes.
Okay, sounds like a few more. And yeah, that's correct. 5 units down would be 1, 2, 3, 4, 5 units down. And then 1, 2 units to the right will give you the 0.40. Now, another way that you got that, you're going to see this pop up. And it's similar to the question that
I'm sorry, what was the answer for that?
I think someone asked again. I thought I heard a sneeze as well. But I think someone asked what was the question answer?
What was the answer on that one? I'm sorry.
Oh, okay, that was A, 40. So it's 5 now. 1, 2, 3, 4, 5, and 2 across. 1, 2.
Thank you.
You're welcome. Now another way that you could do that one, and like I said, you see this pop back up. This was the 0.25 originally. X was 2 and Y was 5. And if you look at this one carefully, if let's say you didn't have a graph and you was like, well, I don't want to have to sketch it all out because that takes too much time on a timed test. So one way you could do it, if you find this easy, is you're going 5 units down. Well, if you're going 5 units down, that's on the y-axis. So that's the same as subtracting 5. And then 2 units to the right, well, that's a +2 direction, right? To the right. Remember what I drew? To the right is positive, to the left negative. Up is positive, down is negative. So going down 5 means on the y-axis, and going to the right means 2. And if you were to add those two together, each one that's there, 2 + 2 is 4, and 5 - 5 is 0. Does everybody see that? And that's how you could do it if you don't have a visual graph. You could try to sketch it out, but like I said, that's going to take some time unless they give you one of those, because they give you the whiteboards, unless they give you a whiteboard that already has a grid. And I'm not sure if they do that or not, but they might give you a whiteboard that has a grid on there already, which will make it easier to count. All right, we're going to have to skip a few, so we're going to turn the page, the one that I'm looking for. Okay, see it? And we'll do a few more on this other side. Number 14, that's what it was. Okay, number 14, let's see if you guys remember this. I briefly went over it with you on Tuesday, last week Tuesday. And it says, which of the following ordered pairs describes the location of a point that lies in the 3rd quadrant? Now, do you guys remember what the quadrants are?
Yeah.
Yeah, I heard
Yes.
1, yeah.
Yes.
Yes, okay. 2 yeses.
Yes.
Can you go over it, sir?
All right, and 1 review, and I'm pretty sure there are some others. Now, remember the word quadrant? You see there, quad, used in a lot of different languages, whether it's French or Spanish. It's very similar to those languages before. So quad, at very beginning, just means it's going to be split into 4, and we call them quadrants. The first quadrant is here, the positive side. All the x values are positive and all the y values are positive in quadrant 1. But then we go in a counterclockwise, anti-clockwise, the opposite of a analog clock. And so quadrant 2 is over here on the left. And I stated this before that sometimes they may ask you, what is the location of a point? What quadrant is it in? Now on the second quadrant, the x values are all, and this
Negative.
say that again?
Negative.
Right, the x values are negative and the y values are positive.
Positive.
They ask you stuff like that. What are the x values in quadrant 3? Right, and so if that's a question that pops up, that's what it's referencing. Quadrant 3, remember we're going anti-clockwise, so this is quadrant 3. And you notice that the x values are,
Negative. Negative.
and yeah, we got negative, negative. And then the last one, quadrant 4.
Positive. Negative.
Yep, so we got positive, negative for the last one. Now that's important. They do ask questions like that, positive, negative. Remember, x, y is in that order. And so they might ask you, what are the y values like in quadrant 4? Every single y value in quadrant 4, in this region here, will always be negative. And that's why it's positive, negative, as you see. And so sometimes questions like that pop up. So you want to make sure you have that. I don't know if you want to take a picture, screenshot, but that's what it's referencing. So I'll leave that up for number 14. Number 14 says, which of the following ordered pairs describes the location of a point that lies in the third quadrant? So think about where you're looking.
-3, -2.
3, -2.
Say that one more time. I heard 2 answers and then it kind of,
-3, -2.
all right, I heard -3, -2. Do you guys agree with that?
Yes.
Yeah.
All right, that is correct.
I'm not clear with Mr. Ree. I don't say that again. I don't understand why we have -3 and -2.
Because -3, -2 is in this quadrant, is in the third quadrant. And that's what the question is asking you, is asking which ordered pair would have a point, excuse me, that lies in the third quadrant. And the point -3, -2, -3 is here, and -2 is here. And so they meet up right smack dab, right in quadrant 3. All right, so that's what that is asking you. It's just asking which point is in quadrant 3 from that list below. And so correct, C.
Okay.
Okay, any other questions regarding the quadrants? There's another one like that, so let's look at number 22. Number 22 says, which point in the square WZYX, so look above, this is number 22 on page 101. Which point in the square WZYX lies in quadrant 1?
Z.
That's B. Point
Okay,
Z.
I heard Z's.
Z.
Z, that is correct. Z is
22, Mr. Ray?
quadrant 1. Did I hear a question?
Yeah, which number was that? Which
That was number
question?
22 on page 101.
Okay, I put B. Which one was it?
It
B.
was B, yeah. B as in
Okay.
point Z.
Okay, got it.
Yeah, no problem. That's correct. I can see why that would be confusing because I thought I heard someone say B and then Z, and I see, yeah. So B, point Z. All right, and there was one more I thought that was in here. Maybe it was in the first page. Yes, number 8. So if you turn the page over to page 99 and look at number 8, it says, which of the following points is found in quadrant 2 of the coordinate grid? So which of the following points is found in quadrant 2 of the coordinate grid?
That would be C. -2
Okay,
and 5.
that's correct. C, -2, 5. And you see that if you look at the signs, they match what we had written there. -2, 5 is literally our answer. If you were to draw -2, 5 on this quadrant, I'm just going to erase all of that. -2, 5 would be, this is -2 on the x-axis, and then +5 is up here. So that point would be right in quadrant 2. All right, so that's how the quadrants work. You see that they're going to ask you stuff about translating and moving points around. And that takes us to one that was similar to the first question. Number, where is it? I just saw it. Hold on. Oh, number 19. Kept looking right past it. All right, so number 19 had caused some issues for some people in the other class. So I'll let you read through it and see if you can figure it out based off of everything that we've done.
Number 18.
Number 19, sorry, on page 101, page 19.
I got the answer, Mr. Ray. I'll wait.
You can send it in the chat if you're finished and you want to know is your answer correct.
Mr. Ray, I got my answers, but I'm using my cell phone. I don't know how to navigate to
Yeah, I
chat.
forget. The cell phones is tricky. It's like you got to either swipe left, right, or up, down. Left and right, I think, switches between me and the presentation, and I think up and down is what brings up the chat box. I think if you swipe up, I think, or just tap it, a menu pops up where you can click chat. All right, I'm just going to start reviewing over how to do this. This is very similar to what I had done when I was explaining the very first one. You see here they have x minus 5. The only thing they did here, they wrote it differently. You may remember for one of the examples, I had it and I put plus, well, if I use the same numbers, I had put like minus 5 and plus 3 and I just added on. The same thing here, instead of them writing it below, they wrote it right next to. So they're saying basically that you're going to move. How could you say this in words? Anyone know how to say this in words? Which direction would the x-axis, would the point move on the x-axis? How many points in which direction? Well, this first one means that you're going to move 5 units.
Negative.
Say it again.
Down.
No, for x-axis, 5
Oh,
units.
for X. Oh, okay.
5 units to the.
Oh, to the left.
To the left, to the left. Anyway, we have y plus 3. And what would that 3 mean?
To the left.
So,
Up.
up.
3. Yeah,
Up
3.
3.
That means 3 units up, right? Remember what I said. Positive on the y means up. Negative on the y means down. And whatever the number is, that's what you do. With the x-axis, negative means to the left. And positive means to the right. So when they say x minus 5, they're saying you're going to shift 5 units to the left. When they say y plus 3, that means you're going to shift 3 units up. Okay, so with that said, they then say the point U on your chart. If you look up top, right above that, about 2 spaces up, you see that graph, and you see where U is located, hopefully. The point U, if I can get a point there, is at 4, negative 5, it looks like. So 4, go away. 4, negative 5. Yeah. So they're asking you if that point U was to be subjected to this translation, where would the new point go? And Salvador had already got that correct, so well done. He had sent that correct answer in very quickly. Anyone else?
Yeah, it's -1, -2.
Yeah,
Okay.
-1,
A.
-1, -2.
A.
Okay, I'm hearing more agreements there. A, and that's correct, right? 5 units to the left, 3 units up. You could either go 3 units up and then 5 left, or 5 left and then 3 up. Either way, it gets you to the same place. But 1, 2, 3, move too fast there. 1, 2, 3, 4, 5, and then 1, 2, 3. And you see that that point is A. -1 is where it touches on the x-axis, and then -2, that's where they meet. And so that's our answer. The answer choice selection there was A. Right? Does that make sense?
Yes.
All right.
Yes.
Okay, how about number 17? Let's try that. That one has words. There's a point is translated down 2 units and ends at point R. How can you find the original location of the point?
The point is translated.
What number are we doing?
Number 17. So we're looking at the graph on top of number 17, where point R is located. And it says a point is translated down 2 units and ends at point R. How can you find the original location of the point?
By adding 2 units to the
Would be
y
5.
coordinate.
Okay, I heard an answer, and I see in the chat, William says B as well. Okay, so I had 2 answers there for B, and both of those are correct. That's how you would do it, right? It's the opposite. Oops. Thought I had control of this point, and I don't. Okay, do I have it? Yes, oh, my screen went crazy. All right, there we go. All right, so this one had R at 2, 3. And it said that these R have been moved down 2 points. So that's correct. We're gonna move the point. If you want to see where it was, instead of going 2 down, which was how we got there, we go 2 up. And which direction are we moving on? The y-axis.
Y.
Y is what goes up and down. So that's correct. Add 2 units to the y coordinate of point R. All right, so with that, that's where we're going to end today, unless someone has a specific question from that section. Actually, one more. Let's do number 23. This is our last one. It caught my attention there. So number 23, there's a square there, points W, X, Y, Z. And Z, I think, was about here. Yeah. So that's Z. And the Y is there. And W is here, I think. Yep. And then, bam. Okay, so can you guys answer that question? We have a square there. Let's see, ignore those points in the middle. But that's our little square. It's W, X, Y, and Z. W, X, Y, Z.
That is 4 and 2.
4 plus 2.
All
4
right.
and 2.
I hear 4, 2, because Z you're saying is 2, 2.
No.
So let me put what Z is. This is going to be point Z. That's the only one we really care about. And so Z, the whole square is moving 3 units to the right. All right, so the whole square is moving 3 units to the right. Can I move this whole square? Let me see. Yeah, so there we go. So the whole square is moving 1, 2, 3 units. And you notice there that Z is now on the point 4, 2, as was correctly stated. And so which choice selection was that?
A.
A, right? So you can see visually, hopefully you're seeing visually how it connects with what we're doing. It's just showing you the translation. people who make video games, they actually have to program that. So like when you see something moving around and you're like, wow, that square is moving. Really, that square is moving on points, right? So even though I'm moving diagonally, I'm actually moving across points, and it can be described there. And so you would program the computer, and then the computer moves it for you, and you're like, wow, it looks like it's actually moving and it's alive, right? But if you got into program game design, you would have to learn how to do translations, we call them. So anyway, that's where we're going to end for that one. And we're moving on. Your homework, just to let you know, is going to start at 102, the next page, and it's going to work its way up to 105. As usual, the student book doesn't go that deep, so it depends on how much we can finish today. We're moving much faster than the morning class. We didn't get there till around the 30 minutes left time, so we should be able to cover a good bit based off where we are right now. And I'm going to switch screens. All right, so we are in the student book now. And hopefully you're still practicing how to do all that stuff we've done. What's this? That's what we just did, coordinate grid. All right, here we are, graphing linear equations. Excuse me, now a linear equation is simply an equation that when you graph it, it creates a straight line, any type of straight line. And there are just three generic straight.
What page?
72.
22?
You said 22?
72.
Oh, 72, page 72.
Thank you.
You're welcome, and George says welcome too, right, George? All right, so we have here a linear equation is a straight line. So that line can be a diagonal line that can go this way or that way, or it could be a vertical line or a horizontal line, right? Any of those type of lines, it can go diagonal, it can go vertical or horizontal. So those are three lines, and when we have straight lines of that nature, we call them linear. You can see in linear, line, so it's basically a line equation, but we call it linear. And you might have heard people say linear before, might have heard the term of a linear nature. Dorcas, do you have a question?
Yeah, I don't know if you're writing anything on the screen. I can't see it.
I was writing something on the screen. I'm guessing it did not show up. Do you see anything now?
No, and I don't know how to navigate my phone.
So what do you see?
Nothing. I just see you and other people.
Try to go right or left. Swipe right or left. Did that help?
No.
There's,
Maybe I log out. I don't know if I can log out and come back in.
yeah, that could possibly work. It might reset it. I'm trying to remember what it looks like on the phone. With the phone, is either a button. Are you on an Android device or an Apple device?
No, Android.
Okay, so I'm trying to remember. I think there's a button there. It's like a little arrow or something.
Let
me see if I can help you out real fast. Where's Google?
Okay, I think I see. Let me see. I see it now.
Okay, perfect. So you can see it?
Yes.
You see lines?
Yes.
Okay, perfect. You're there. All right, great troubleshooting. And there we go. So these are linear lines. You have diagonal lines, right? Diagonal. And then you have horizontal lines. And you have vertical lines. Now, a line is basically a collection of points. And so technically, we have an infinite amount of points on one line. That's what a line is. It's just like, and all the points right next to each other, and no matter how small, and they're so close together that it looks like a line. And because of that, we can draw a line if we're just given 2 or more points. As long as we have 2 points or more, we can draw any type of straight line. So typically we say 3, but 2 lines would be enough. Now this is where what we did on lesson 5 comes into play. You may remember doing tables. And I'm just trying to find that real fast. Okay, you guys remember doing that? We were doing tables, right? This is where the tables can really come into play, because remember those tables represented X and Y, as you see here. And we're just dealing with the X and Y's. So that's exactly how we graph. If we go back to here, remember that was the linear function or linear equation, we call them. And we can take the X and the Y's and substitute to find corresponding values. Hopefully you remember doing that, because that's how we graph an equation. We simply graph them by substituting values. Now, it depends on how they write it out. I'm not sure if you're going to actually draw a line. They might ask you to plot something. I'm not too sure how it will look on the test. But basically, because these points are corresponding pairs, that means that they will satisfy the equation. Remember, I said just substitute. So if you substitute 2 into the equation, because that line represents the equation right here, because that line represents that equation, if I substitute the value x equals 2 into the equation, as you see here, it will give me the corresponding y value, which in this case is 5. Same here, if I substitute x equals 0, and x equals 0 is here, then when I substitute 0 in there, as you see, and I work it out, I get -3. And then once I get those 2 points, if you were taking a paper test, you would put a ruler between that and draw a straight line, and there you have it. I'm not sure if on the test they're going to actually draw a line. If they do, they might give you a line tool like this, where you could just draw a line through that. I'm not too sure how it will look on the test, to be honest. But basically, that's how you do it. Now, if you want more values, you can create a table. Just like we did in that previous lesson, you could use your calculator to do the table if you remember how to do that. So we have X and Y. We typically choose a negative, a 0, and a positive. And we try to choose numbers that are close together, because that makes the numbers smaller. If you choose -6, you're going to get a big number, and it may not even fit on the graph. And so you want to try to choose numbers that will fit in the graph, and that's normally right here in the middle are the numbers that you want to choose. So you are the one who chooses the numbers, and so you make your X and Y table, and you can put in 0 and 2, and just like you see here, when you put X equals 0 and you substitute like we've been doing all this time, and you get -3. You put 2 in there, you work it out, you get 5. And that 0, -3 represents a coordinate point that you can put on the graph, and if you have 2 or more, once you get those points, you can connect them with a line. Does that make sense?
Sorry, just try to go over it so let us understand, because
Well, you remember, we only have 2 weeks left, so you got to really put on your thinking caps. All right, so let me show you some more connections here. Because these points are on the line, and remember, the line represents the equation. That means if I chose any of these points, like 2, 5, and I substituted it, do you remember I said if all else fails, substitute? Because if it works, your basic, this crazy computer. If it works, it shows that which one is the correct answer. So if I took the point 2, 5 and substituted both of those in there, I should get a true statement. Now here, my X is 2 and my Y is 5. And so that means I substitute Y for 5. 5 is equal to 4 times. I replace X there with 2. And I should get 5 on the right side when I multiply it. 4 times 2
yes.
is, did I do that right? Hold on. Yeah, 4 times 2 is 8. And 8 subtract 3 is going to give us 5. And so you see it works. And that's why I said to you guys before, if all else fails, substitute. You can use the concept of substitution to either find the missing variable or to prove whether something is correct by substituting both of them in. Remember, what you're substituting represents the X and the Y's of coordinate points. That's the connection. And hopefully that's what you're seeing, the connection that's being repeated in all of the lessons. They're trying to show you the connection of algebra. Algebra just represents the unknowns, And if I have one of them, I can find the other one if I'm dealing with coordinate points. If I have one of the coordinate points and I substitute it into an equation, I get the corresponding value. You could think of it as best friends or spouses, white on rice, right? Inseparable pairs. If you have one, you can find the other. If you have the other, you can find the one. If you have both, you can see if they are the solution to the equation, if they come out to be true. All right, we're going to try a few of the questions that are on here. And so if we scroll down to number 1, it asks, which ordered pair is a solution to 2x plus y equals 5? This is very similar to the very first question asked by George. That one was a 2-pair system. It was an equation that had 2 of them, and you had to be correct for both. In this scenario, you just need to find one, right? It's just one equation. And if you don't know what to do, if all else fails, substitute. And so that's exactly what you're going to do. You're going to substitute your x's. This first row all represents x's. And remember, the second one represents y's. And you're going to choose one by one, and whichever one works is the correct answer. And if all else fails on any question where you see something like that, you can literally do that if you don't know how to solve. All right, so for the first one, A is -1, so we have 2 times -1, replace x with -1, and then y is 3. And we want to see, will this equal to 5? 2 times -2 is -2 plus 3, does that equal to 5?
No.
No, -2 plus 3 is 1, and 1 is not equal to 5, so A cannot be the correct answer. That means that point is not on the line. All right, so then we're going to try B.
1, 3.
So x is 3, so we have 2 times 3, plus y is what?
Plus y, which is
-1.
-1, and we want to see, will this equal to 5, as the equation says. 2 times 3 is 6. 6 plus -1, does that give me 5?
Yeah.
Yes. So because they are both 5, that means this is the point that will be on the line. And so if I was to draw this line, it would look something like this, right? If I had an x and y plane, it would look something like that. Basically, it's saying that the point 3, x is 3, let's say that's 3, and this is -1. Point 3, -1 would be on the line. That's what it's saying. So when we check to see if something is a solution, it means if it's true, that point can be drawn on the line that represents that equation. Hopefully that's starting to make more and more sense.
Yeah. Okay.
All right. Any questions so far with number 1?
Sir.
Okay, I'm moving on to number 2. Number 2 asks us, which of the following ordered pairs is a point on the line of the equation x plus 2y equals to 4? We're doing the same thing, and it looks like from the questions that they normally point out, this is normally what you're going to be asked. You're going to be asked either to substitute both or one. All right, so number 2, all you're doing is trying to see which one of these will be true. So what would I have to do there?
Multiply.
Substitute, right? And that's the equation, x plus 2y. So for A, I want to see if A is true. So what do I put for x?
-2.
-2, and what do I put for y?
0.
0, and that means it has to be equal to 4. If it is, then that is the point that makes it a solution. Or another way to say it, it's a point on the line, right? Those are synonymous phrases, a solution or a point on the line. So what's 2 times 0?
2.
0.
Careful, 2 times 0 is 0. And -2 plus 0 is -2. Does that equal?
No, sir.
No, they are
No.
not equal, so A cannot be the answer. Then we try the next one. We want to see if B is going to be the correct answer. Some of you might be able to do it in your head
1
after more and more practice. X is going to be 1, and what do we substitute in for Y?
3.
3.
3.
We want to see, does that equal 4? So we have 1 plus, what's 2 times 3?
6.
Is that going to equal to 4?
No.
No, sir.
No, so B cannot be the answer either. So then we tried C. So X is going to be equal to what?
It goes to 0.
0, that's correct. And what is Y equal to?
Now he says we have no time to waste.
2.
When he slow-
Y is equal to,
2.
we're doing C now, so what is Y equal to?
4. 2, sorry.
2, right. But when we multiply those together, that's when we get the 4. And does 4 equal to 4?
Yes.
Yes. So that means what's our answer there?
0.
C.
C. C would be the answer. All right. And if I was to draw that out, just to show you what that line looks like, as X equals 4 and Y would be 2. This is what that line actually looks like. And if you took that point 0, 2, look where 0, 2 is, right there. That point is on the line. Whereas the other points, if I was to take them, like for example, 2, -4, that's the last one. 2, -4 is not on the line. And so visually, you can see it. But when you don't have a visual, that's what you're doing. You're substituting the values into the equation because it represents being in the line. So you're putting the points into the equation. Because if the point is in the line, then it shall be in the equation. Hopefully that's starting to make more and more sense. So with that, try number 3. Which ordered pair is a solution to 2x minus y equals to 0? And this one is actually pretty easy. So go ahead and try number 3, and you can send your answer in the chat.
Mr. Ray, I sent him my answer.
Mr. President, you have not condemned these actions.
Mr. Ray?
You have not condemned this.
I sent you a response back. Did you see it?
Okay, let me look for it. I don't know.
So just in case you don't see it, I hit send back. That's correct. All right, we're going to
I
start.
saw it. I forgot to put the parentheses. Sorry
Yes.
about that.
Okay, so you did see it. All right, perfect. All right, so let's go ahead and go over this one. Sometimes we're blessed that the first one is the correct answer. In this case, it is. If you substitute the 0 in there, 2 times 0, subtract 0, right? X is 0, Y is 0. You get 2 times 0 is 0. Be careful not to put 2. You're multiplying, not adding. And 0 subtract 0 is indeed 0, and there's your answer, A. And so there's no need to do the rest. You can if you want, but if you get it correct and you know you've done your calculations correctly, there's no need. All right, so any questions with that? Number 1 through 3. All right, so number 4 is an example where you might have part of your coordinate pair. You're missing the other one. and you're trying to figure out what that is. And remember our fail-safe plan. If all else fails, and you look like you can substitute, then substitute. So what would you substitute in there?
Which number is that?
Number 4. Don't let this confuse you. It's still pretty similar. What can you substitute in there?
What is the missing X?
What do you have? What value can you?
In 3.
You can substitute in 3. And 3 in for what?
The X.
No,
No, the Y. Sorry.
the y.
No,
Remember
3
x,
goes
y.
to Y.
So we can replace y with 3, and we're left with 3 equals to 2x plus 2. Now, hopefully, you say, oh, we've done that many, many times. How do we solve for x now?
You gotta substitute one of the
We
answers.
substitute.
No, we're solving, right? We're finding the missing x value. How do you find x?
Subtract the 2.
Oh, we're
There we go.
refracting.
Subtract the 2, and what we do to one side,
Do to
To
the
the
other.
next side.
do to the other side, right? And so the 2's over here cancel, and what are you left with down here?
Positive 1 equals 2x.
All right, and then how do we get x by itself?
Divided by 2.
And on both sides, and so we end up with
1
x
half.
equal to 1
equals 1
half. And which answer would that be?
D.
C, that's correct. So C would be the answer for that one. Oh, okay, Jacob. Yeah, that's unfortunate there. I don't even know what I could tell you there. You got to see if someone has a charger like yours. All right, so we have x is equal to 1/2. So remember, for the most part, for a lot of the algebra problems, a good bit of them is going to have you substitute values. If they ask you to solve, that means that the solutions will be down there, which means if you don't know how to solve it, you can do this, right? What we're doing for 1 through 3. You can substitute back in there and see what works. Whether it's a set of points, or let's say they had A, B, C, D, and over here they had x equals 5 and x equals 3. Well, you take x equals whatever and substitute and see if it works. If you don't know what you're doing, right? It doesn't matter how complicated it is. Let's say they give you something like 2x cubed minus 5x plus 2. You take that x and you substitute in there and see if it works, right? If it's a coordinate point, sometimes it might be written like this, y equals 2. You can take that and substitute. And the beautiful thing about your calculator, you could type that in your calculator just as you see it, which means this is an example, right? Just keep that in mind. You could type in your calculator, let's say the answer, you're substituting in 3. You could say 2, open bracket 3, put your power to a 3, 5 times 3 plus 2. Put that right in your calculator, bam, you have the answer, even though you may not know how to work it out. Hopefully, I'm really getting to you guys. You're hearing this, and you can implement that on the test. If you get stuck, you're like, I don't even know how to do this. I haven't seen this. Substitute, if you can, that is. All right, that takes us now to number 7. Very similar to what we've done before. It says point A lies on the equation x plus 2y equals to -3. Which of the following are other points on this line? What could I do to try to figure out if these points are on this line?
Substitute.
Substitute. Just go ahead and substitute. So we're going to start with the first one. What would I put in for x?
0.
0. What would I put in for y?
-3.
-3. And hopefully you can see already that is just not going to work. 2 times -3 is -6. So we know A is not going to work. So let's try B. What is my x value now?
-1.
-1 plus 2 times what's my y value?
2.
2. And that's going to equal to -3. So we have -1 plus what's 2 times 2?
4.
4. And what's -1 plus 4?
+3.
+3. Is this the same?
Nope.
No, be careful. A lot of people say, oh, that's the answer. That is not the answer. If this was your bank account this morning, and let's say that represented 1,000. So let's say that was $3,000 in your bank account. And you wake up tomorrow and it says -3,000. Are you gonna say, woo, that's the same number?
Nope.
No, you're gonna call that bank and say, what happened? What happened? Why do I have, right?
Yes, I see.
Okay, I hear someone shouting out the answer. I didn't pick up who it was.
D is Dorcas.
Oh, Dorcas. All right, Dorcas is saying it is D. Well, I can't even see what D is. Hold on. I got something.
-5
All right, let me scroll up.
plus.
Okay. That clear all that stuff. All right, so Dorcas is saying -5. We're gonna trust Dorcas and we're gonna skip C. All right, so we're gonna say Dorcas said C is wrong. And
Dorcas is right.
-5 plus 2 times 1, and I'm hearing someone
She's
backing
right.
you up, Dorcas.
Yeah.
-5 plus 2, and -5 plus 2 is indeed -3, and that is correct. Be careful of those tricky ones that they try to get you. Well done, Dorcas and Salvador, for verifying that she is correct. All right, so that's what you can do if all else fails. All right, we are covering a good bit of information, so you want to make sure that you are constantly practicing as much as you can and still reviewing the older stuff. All right, now something that I want to go over, because we definitely change of plans and got to finish up by next week. But if you turn, and it doesn't matter what book it is, whether it's an English language arts book, it's all there. If you turn to the beginning of any book in the Roman numeral page section, and you're looking for page 14 in Roman numerals, that's page XIV. If you turn there, you're going to see a page that has formulas. Now, these formulas are on the test, page 14, XIV for Roman numerals, page 14.
On workbook or student book?
And it doesn't matter what book, all the books have it on the same page. But just to be consistent, we're still on the student book, so it'd just be best to hold onto that.
Page
But the Roman numerals part are the exact same in any book that you have. Whether it's social studies, science, the Roman numerals are all the same. So if you turn there to XIV, you're going to see formulas for the GED math reasoning test. Now, these formulas you don't have to memorize, but on the test, there's like a drop-down menu that allows you to see these same formulas. Now, remember, I had said to you guys before, the geometry section is easy because it's basically algebra and substitution. You have to identify the shape and then choose the correct formula and then just substitute the values in. And as long as you can do algebra, you've got it. Right, so with that, what you see here on the screen is the distance formula. Now, the sad thing is they don't give you the distance formula on the formula sheet. So I'm not sure. No problem, Shinara.
I've not seen that page, the page where you are there.
It's XIV on the Roman numerals. Stands for
XIV.
page 14.
Okay. I've seen it. Okay, yeah.
All right, so on that page is a bunch of formulas. And it will possibly do you well to try to learn how, get used to them, to the names and whatnot, because you can substitute values in there, and that's how you can work out things. All right, so with that, what we see here is the distance formula. Now, sadly, like I said, the distance formula doesn't appear on that list. So I'm not sure if they want you to memorize it. But the distance formula is how you find the distance between any 2 points on a coordinate grid. Now, basically, we understand the concept of the distance. The shortest distance between any 2 points is a straight line. And that's why some people cut across grass when it says don't walk on the lawn, because we can see it's shorter if we make a straight line. Instead of walking around, and in this case, walking horizontally and then vertically, instead of walking that way, we may notice, you know what, it's shorter if I just cut straight across. And that's because we all know just intrinsically that the shortest distance between any 2 points is a straight line. So when you're measuring distance, that's what you're doing. You're measuring the line segment between 2 points. Now, the way that we do it, we have to use X and Y values. And so we incorporate where we should travel. So imagine the straight line is walking across the grass, and then imagine the X and the Y values that we need are actually staying on the pathway. And in order to figure out what those x values are, we first have to see how to do it. And that's what this formula comes into play. You notice here, they use what we call subscripts. Those little numbers there just represent the order of numbers. And so it just means the larger number or the second value. So the first x value is here. It's right here on this line. It's the 0. And the second x value is here. Notice that the distance between 0 and 2 is how many units?
2,
1.
2 units.
3, 3.
3 units.
2 units. Remember, you don't count the 0. You count when you make the step.
Okay.
All right, so that's 2 units. Now, all this formula does is show you how you can write that. And all they say is take the bigger x value, which they call x2. So if we had here x2 minus x1, the x2 is the number 2, and the x1 is number 0. And that's how we could tell that the distance between those 2 points is 2. Does that make sense?
Yeah.
Then we need to find the distance between the y values. Well, the distance between those y values, you can count it. That's 8 units if you was to count that. But sometimes you want a faster way to do it because it might be hard to see what those values are. And once again, you could do the same thing. This represents your bigger y value, and this represents your smaller y value. Your bigger y value is 5, and your smaller y value is -3. So if you were to subtract those two, you would get 5 subtract -3. And remember the 2 negatives here, what do we do with those 2 negatives?
Positive.
That becomes a positive. And what's 5 plus 3?
8.
8. That's exactly what you see there. So what this formula does, it just allows you to find the distance that you would travel from in the horizontal and the vertical. Now, the rest of it comes from something called the Pythagorean theorem. Now, it's named after a Greek guy, but the Egyptians and Babylonians and many other peoples had already known about it. That's how they were building the pyramids. If you look closely, it creates a triangle. And when you look at the pyramids and different objects that have been built around many civilizations, they all knew this, right? It's a principle that can be proven and was known by many civilizations, but it's named after a guy named Pythagoras. And so basically what all these civilizations knew thousands of years ago is that if you add these two distances together and square them, and then basically take the square root of them, and we'll learn more about this with Pythagorean theorem, then you can find the distance between the 2 points. And that's what the formula is. And so when you see those values, you're simply looking for what your coordinate points are. You're looking for your first x and your first y, your second x and your second y, and then you're going to just use this formula to find out what the distance is. So this is the same thing here. And so 2 subtract 0 is 2, so you end up with 2 squared. 5 plus 3 is 8, and so you end up with 8 squared. 2 squared is 4. 8 squared is 64. And then 4 plus 64 is 68. And then you can use your calculator to find out that answer. And most times they ask you to round it to the nearest tenth, or it might just be written there. And so rounding that answer to the nearest tenth gives you that the distance between those 2 points that we saw on the line is approximately 8.2, or 8 2/10. Now I know that's a lot, so we're going to do another one from start to finish. But hopefully you understand how to utilize the formula. Like I said, I don't think they want you to memorize it. So more than likely it will be in a question, but it would do you well to know it just in case. If you went to high school, they require all high school students to have it memorized for the exit exam. So if you're graduating out of 12th grade, you actually have to know what that formula is. All right, so we're gonna go on to, I think it's number 5 now. I think it's number 5. Yes, number 5. Actually, we're just gonna go to number 6. I'm gonna jump the gun there. So we don't have all day. And if we have time, we'll go back to number 5. So number 6, we're gonna find the distance between these 2 points, the point 25 and the point 43. Now remember, if we were to draw this out, it would be 2 points and they'll be connected So it'd be like 1 point would be here, 1 point would be here. We're trying to find that, the distance. Now 1 point would represent 2, 5, even though that doesn't really look like a 2, 5. So let me make it look more realistic. If you were to draw this out, the point 2, 5, and you don't have to draw it out to do this. I'm just doing this to help you to visualize what we're doing. So 2, 5, and then 4, 3. Right, so that's 2, and that's 4, and then 3 and 5. So this is what it looks like, and you're basically trying to find that distance. And remember, we want to find the distance between the x's and the distance between the y's, and that's what the formula represents. So it's the square root of, we say x2, the bigger x value, subtract the smaller x value squared, plus the bigger y value, which we say y2, subtract the smaller y value, and we square that. Right? As long as you have the formula, makes it easy, and I'm hoping that they just give it to you. So we have here the square root of, you look for the bigger y value, x value. What's the bigger x value there?
4.
4. So we say 4 subtract 2 squared, plus we look for the bigger y value. What's the bigger y value? 5. So 5 subtract 3, and then we square that. All right, so then we keep going to find the distance. 4 subtract 2, that's going to give us 2 squared, plus 5 subtract 3 gives us also 2 squared. And remember order of operation, so you do the squares first, the exponents go first. So 2 squared is 4, 2 squared is 4, so we're left with square root of 8. Now we just have to find the square root of 8, and that's where your calculator comes in. Remember, if you want to get a decimal, if you're on math print mode, you're going to have to put square root 8 and then like a decimal point, just so that your calculator knows to get a decimal as an answer. If not, your calculator is going to give you 2 square root 2. And you see that is not a choice selection. So make sure you put a decimal point when you take the square root of 8. You're going to get a long number there. All right, that's the correct answer, Latavia. You're going to end up with 2.82, and I don't remember what comes after the 2.
8.
I done it this morning. What is it? 8?
8. Yeah, so it's going to
Yeah,
be
8, and then followed by a slew of other numbers. They want you to round it to the nearest hundredth, and the nearest hundredth would stop right there.
Right.
The digit to the right of 2 is 8, so it's going to round that 2. I feel like something was crawling on me just now. To a 3, so it becomes 2.83 as the final answer. All right, that was a lot. Any questions with that one? All right, so I skipped number 5, which is a little bit easier, as long as you remember what the origin is. So go ahead and try number 5, but before we do that, what is the value of the origin as a coordinate point? Well, the origin, remember, is where you originate from. That is the point 0, 0. So go ahead and try number 5. You're doing the exact same thing. Remember, 0, 0 is going to be one of the points, and -4, 3 is the other. Now, just to be honest, it doesn't matter which one you choose to be the bigger one, as long as you're consistent, that if you choose this to be the first or second, that you say x2, y2. The 2's have to be together. Remember, they are inseparable. They are white on rice. So as long as you're consistent, it doesn't matter which order you do it. All right, so you want to try number 5. Once you get your answer, send it in the chat. You notice you get a whole number, so it should make it easier to do.
All of a sudden, you got again a church. You say, I know they don't explode, they don't get a very big mansion somewhere or don't buy land. Somewhere also, Christian very to maybe land settlement. Now, this is the go. You hadn't discovered they don't build a very giant house. Against that time of the year, they just go one time, they go make this CIG certificate, certificate. I don't know, governmental organization. apply down, assign, or do it with our thing. You take our one time to apply for land. A church now, you don't to buy land. You have to church, you talk when they give land to any new they out, you go to land as well for them. We have call out of school. So I see chief, you are looking land for you. A month of letter, you need the more money from it. Can't see my show there, to put car book today. Tomorrow let's have big block around it. Before I know, until we don't start applying, you know. Do y and x. 6.2 y. Y equal to x. So, I know the likes of it. It's an animal.
All right, so we have there's a few answers that have come in. One of the answers is correct. So let's start going over it. If you still see the answer, you want to send it in before I go over it, you can still do that. Okay, got 2 correct answers. All right, so remember the origin is 0, 0. So if this was to be sketched out, the origin is here at 0, 0, that's the origin. And x -4 and +3 is about here. So it doesn't really matter which one is your y2, as I said before, but If you want to stay in terms of direction, I mean, it doesn't matter as long as you're consistent. So let's say if we call that one x2 and this one y2, and this one would have to be x1, y1. Now, technically, you could choose the other one, but it just makes it easy to be consistent. Remember the formula. Does anyone know the formula yet? D is equal to the bigger x value, x2 minus the smaller x value, which is x1, and you square that, plus the bigger y value, subtract the smaller y value, and you square that. All right, so D would be equal to, you just substitute your values in, what's your x2, meaning your smaller, bigger x value? That would be 0. Everybody see that? 0.
0 minus 4.
Right, 0 minus 4, right?
And
the
squared.
So, but you want to be careful here because you're saying 0 minus what? Negative
4. Oh, negative 4.
Right, 0 minus negative 4. So it doesn't really change your answer, but you want to be careful for other scenarios. And then we have 0 subtract 3. I heard somebody say 3. All right, so that gives us, if we work inside 0, this turns to a plus. So that gives us positive 4 squared, excuse me, plus negative 3 squared. And remember, put the negatives, always have your negatives in parentheses. If not, you're going to end up with the wrong answer if you put it in the calculator. Your calculator only gets the correct answer when squaring negatives if you put parentheses. If you don't put parentheses when you're squaring, you get the wrong answer. All right, that's correct, Latavia, as well as Dorcas and William had also got it right. So square root of 4 becomes, the 4 squared becomes 16. Remember to follow the order of operation.
Minus 7. Minus
Negative
9.
3 squared gives you positive 9. If you don't use parentheses in your calculator, you will get a negative number where you should get a positive. Remember, teachers don't say it because we want you to do extra work. You say it because we want you to get it right. If you don't put parentheses, you're going to get 7 as an answer. And notice they put 7 there because they are testing to see who will follow the instructions of using parentheses when you square versus those who do not. We talked about this before. Your calculator here is going to give you negative 9, whereas the calculator here will give you positive 9. And those are the two answers in the middle. So the correct answer, 16 plus 9 gives you 25. And if you do that, you get 5 as your final answer. All right, so 5 is the answer. That is selection B. Be careful of squaring negative numbers. Always put parentheses. If you need to put an asterisk there to remind you, please do so. But you want to remember, always put parentheses. The safe thing is to just always use parentheses. That way you don't run into any issues. All right, that's how you do that one. Now they do have some challenging ones there with number 8 and number 9. I can see that. Was anyone copying that? But we do want to cover the basics, so we're going to skip 8 and 9. Remember, for homework, you want to work in the workbook. I forget what pages. I think it's 102 to 105 in the workbook. And you should see similar problems to those two. You can always try number 8 and 9 at home as well. But the homework, remember, 102 to 105. And we're going to actually look a little bit further. Today, we're going to push the envelope. And hopefully you can stick. We're moving on to the next part there. Slope. You'll be often asked about slope. Now, deep down inside, the average person does have an understanding of slope. It's just that when we mix it with algebra, sometimes we can forget what we already know. Now, slope is simply when we measure the steepness of a line. So slope is when we measure the steepness of a line. So to give you an example, this is a pretty steep slope. If you used to try to drive your car up here, do you think your car would do well?
Not quite.
Yeah, most people's cars aren't going to do too sharp. But how about on something like this? Do you think your car would do well?
Yeah, it's a little bit.
Yeah, that's an easier one, right? So this is not as steep. So this is not that steep. And the other one, this one's really steep. That's almost a vertical line. And so you would need a 4x4 probably. There's a lot of engine capacity there, like a V6, V8, right? You're gonna need some off-road tires to grip, and you're gonna have to have nerves of steel, because you're probably gonna be scared going up something that steep. And so what we say is those are what we call slope. It has a steep slope. You might have heard the phrase before. Well, it's the same because we're dealing with linear lines. You're going to be asked about slope. Now, to go even further about slope, remember everything we do in math and even in language arts, when we read from left to right. We count from left to right when we write numbers. And so even when we look at the slope of a line, we're going to do so as if we were traveling from left to right. So if I drew a line this direction, do you think this will be a negative slope or a positive slope?
Negative slope.
It will be a negative slope, right? We read and count from left to right. So remember, I said we'd be driving the same way. So this would be like going downhill. And so this would be a negative slope. And that's what they're going to be asking you. They're going to give you a line and they're going to ask you, is this a positive slope or a negative slope? And you could draw a person on there if you needed to, right? It's a negative slope. How about this one? What type of slope is that?
That's a positive
That would
slope.
be a positive slope, right? Because if you were driving, you'd be going uphill, positive. Whereas the other one, you're going downhill, negative, right? Uphill versus downhill, left to right. Okay, how about another one here? And so these are important definitions that I'm putting up. So we have negative slope, positive slope. What if I had something like this? What would that be in terms of a slope?
I think, can we see the number?
I don't see.
I can't see it on my screen.
You might be
I
able
can't,
to
I can't see.
You might see
can't
it, but I try to put it right next to the other line, so you might make it out just a bit.
Oh,
How
straight
about that
line.
one?
Can we see straight line, straight slope?
A straight line.
Okay, but what would we say about its slope? If we said the one's a positive slope, one's a negative slope, what type of slope would this be?
It'd be a negative because you read from left to right.
Well, if you were driving,
Uh-huh.
what would you say?
It'd be
Positive.
No, positive slope means you're going uphill.
Okay.
It'd be a negative.
No, negative slope means going downhill.
Oh, it'd be
Equal.
neutral.
Can we see
Okay.
straight line?
Said
Equal.
neutral, right? So what is neutral? Neutral means that there's
Neither up or
Zero.
zero, and literally that's what we call it. It doesn't have a slope. It's zero
Okay.
slope, right? So the slope is at zero, right? Has no value at all. It's not positive. It's not a negative. It's zero. So those are our three basic defined slope. There is another one that pops up, and I'm trying to use common sense to help you guys with every single one of these. What would you call that? You decided you're driving. You come up to something like this. Are you going to try to drive up that?
Vertical slope.
Oh, you better stop.
You need to stop. You're going to drive right into that. So we actually have a name for this mathematically. You cannot drive up that. It doesn't, and you don't want to say it doesn't have a slope because it could confuse you with this. And so what we actually say, we say it's undefined. It's the same thing that pops up on your calculator when you try to divide a number by zero. You guys remember we talked about that, dividing by zero? You might want to review that if you've forgotten it. But that's why you have to be constantly studying so nothing goes away. But so once again, we have a negative slope from left to right. You're going downhill. And it could be a negative number. So like -5, right? Could have a -6% slope. It could be a zero slope, right? Flat. Could be a positive slope. And that positive slope could be a 6% increase. 6% incline. And then you can have a zero slope, we said that, and then undefined. It's like you're trying to be Spider-Man car. It's just not going to happen. You can't drive up a straight wall. And so you can remember that to be undefined. So those are the three names that will pop up. And undefined, hopefully you remember, that is the same as dividing a number by 0. If you try that on your calculator, I can't remember what comes up. It might say divide by 0 error. Some calculators come up and they say undefined. You may even remember that. We did a question where it says, which one of these x values would make it undefined, right? It's the same concept there. We're going to try to make that connection. But like I said, there's a lot of information. So you do want to be reviewing and studying as much as you can. All right. Any questions about the description of slope? All right. They're listed here again, positive, negative, or 0. And I wrote the one up top here because you are asked sometimes about an undefined slope. Okay, now the way that we actually define slope is common sense again. And that is dividing, or we say the ratio between the rise and the run. So many times, and we use the word M, we use the letter M to represent a slope. Introduce that soon. So slope, we typically say, is the ratio of rise to run. Now that is just a nickname in a sense, because you know when you really look at it, you're like, we don't always rise, but it's just to help you understand what we're doing. Basically, you're finding the change in the y values divided by the change in the x values. If you've taken science, you might have seen delta y, which means the change in y, over delta x, which means the change in x. Is actually the same as when we did rates and ratios, right? We said the ratio. Speed is an example of that, the ratio of miles to hours. But anyhow, what does that mean? Well, if I was to draw this out, we're going to do that down bottom. And I think they have it written out. Yeah, so they have the rise over run. Now, typically, we use the letter M to represent slope. So you're going to see that a lot, the letter M. So when you see M equals to something, in math, there's no other letter that is generally used for M except for slope. So if you're seeing something with a graph, an M is referencing slope. Now, the way that it works, if you look at this carefully, is just like a staircase, right? If I had a staircase that looked like this, would you feel comfortable climbing that staircase?
Yeah.
Yeah, it's not a steep slope. Let's say you went to some place and the staircase looked like that.
That would be difficult.
Yeah, that would be pretty hard, right? That's a steeper slope. And that's, if any of you guys have done construction or carpentry, you should have a general idea of a stairwell and how the slope is found, right? What you're basically doing is you're looking, if you want to see how steep a staircase is, what you're looking at is the rise over the run. And so what you're really doing is you're connecting the corner points, and it depends on how you want to look at it. Erased it. So if you used to connect each of these corner points, you will literally draw a line. And that's why some people can put a ramp right on the stairwell and convert it to something else, right? You can convert it to a ramp if needed. And so the way that we're doing it is literally the rise over the run. The rise of the step over the run of the step, right? The rise of the step over the run. The rise of the step over the run. And that's literally what a slope is. Sometimes it's called gradient. So if you learned it as gradient, it means the same thing. Depending if you're from a non-US country, sometimes the word gradient is used pretty often instead of slope. They both mean the same thing, gradient or slope. And so the way that
That's true.
Say that again. All right.
Yeah,
so
I said that's true.
Okay. So the way that we count it is, once again, very, very similar to the distance formula. We simply are counting the change in the y values. And the same way we did the distance formula is the same way we find, is very similar. If we want to find out what that step is, right? Imagine that's a stairwell. and it's consistent. If you wanted to find out what that stairwell was in terms of its slope, is it a steep stairwell or not so steep? What we do is we take the change in the y values, and remember the change or the difference in the y values means take the bigger y value, which we call y2, and subtract the smaller y value, which we call y1. And so if I want to see what my rise is, I could count it, 1, 2, 3, 4. So it has a rise, a vertical distance of positive 4. Or I could use my understanding of y2, y1. I could take the second y and subtract the first y, and 4 subtract 0 gives me 4. The same thing I would have done if I just counted it with my eyes. It's no different with the x. If I want to see how the horizontal part goes, well, that's, if I change the color and make it stand out, it's 1, 2, 3. So I went 4 units up and 3 units over. It's no different than a translation. And so if I was to find that one, that's my x values. Well, if I took these two x values and I subtracted them, the bigger x value, subtract the smaller x value, well, that's 0, subtract -3, and we could see that already. It's going to give us 3. And so if you have it graphically, you could just count it. But sometimes it's not given to us graphically, and so we have an equation that does the exact same thing we can visually see. And that is simply subtract the two values, right? It's no difference than if I said how far apart is 2012 than 2020, right? You say, okay, I'll take the bigger number, 2020, and I'll subtract the smaller number, 2012. That's exactly what we're doing. Y2 subtract Y1 literally means like 2020 subtract 2012. That's how we find the distance between anything. And so in math, we just translate that generically so that it works every single time as the bigger y value, y2, subtract the smaller y value, y1. And then for the x values, the bigger x value, x2, subtract the smaller x value, x1. And it's no different than just counting the points as rise over run. And so your rise is 4 and your run is 3. And that's the shortcut way we say it. It's kind of like a nickname, you could think of it. So if I wanted to count that, I'll simply say 1, 2, 3, 4. I'll put 4 for my rise, and then I count my run, 1, 2, 3. And there's my slope. If they didn't give me a graph, that's where this one comes in, and I can subtract the two. Now, if you remember, if you look at page XIV, page 14, you can find that equation. So you don't have to have that equation memorized. Yes, Dorcas?
So, Mr. Ray, in essence, the X is the run, and then the rise is the Y.
There you go. And we go in order. So we typically say rise of a run. That way it's no confusion. So the Y values first divided by the X values. Now on the test, let's say they don't give you a graph, right? Such as this one, number 1. And you're like, man, I don't remember the formula. They give you a formula sheet. So if you go to page XIV, on the test, there's a drop-down menu, and you click it, and bam, up pops the formula for a slope. So if you keep your finger back to where I had showed you before, XIV, page 14, Roman numerals, it's going to show you the slope formula. Now, one of the schools I used to teach at, the students actually had to memorize every single formula. So you can imagine how that was. All right, so we have the slope is y2 subtract y1 over x2 subtract x1. What helps a lot of people is to label them. That way you don't get confused. So x1, y1, and then we call that x2, y2. If you don't need to do that, it's fine, because you could just remember, say, take the bigger y value, subtract the smaller y value, then take the bigger x value, subtract the smaller x value. Right? Either way gets you the same. 4 subtract 3 is 1. Over here, you're going to add those two together. So 1 plus 1 is 2. And then what is your answer for this one?
C.
C. And that's how you find the slope of a line. You can either look at it graphically and count it yourself, or if they give it to you without a graph, you go to the equation page, look up the equation if you've forgotten it, and then make sure you remember to be consistent. By consistency, you cannot have x1, y2. That is not being consistent. You cannot have x2, y1. That is wrong, 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 wrong. It has to be x1, y1. You treat them like a spouse or twins, or an x2, y2. So that's what I mean by consistent. It doesn't matter if you mix them up, as long as you have 1 and 1 for each of the x and y's. All right, so that's how you find the slope of a line using the formula. Remember, the formula page is there and is on the test. You click a drop-down menu and all the formulas pop up, and then you can just substitute your values. Any questions with number 1?
No, sir.
Okay, did it make sense?
Yes.
All right, it makes more sense if you study. If you don't practice and study, believe me, you're gonna forget this stuff. Anyone remember my 4-digit number I gave you guys? There's only 4 digits, but it shows how easy it is to forget something simple. So if we can forget a 4-digit number, because I don't remember what the number was, but if we can all forget a 4-digit number, what would happen if we don't practice this? We will forget it. Not because we can't do it, just because we're humans. And we have so much stuff on our minds. If we don't tell our minds it's important, we will forget. All right, so number 2, we're going to try this one as well. You can turn the page there. We have about 5 minutes left. So number 2 says the following points lie on line A. So they show you what the points are. I'll point them out to you on the screen. We've practiced how to identify them. So point A, 2, -4 is here. -2, -4. So that's point A. Sorry, that's line A. So I'm going to call them A, B, C. So that's point A. I'm going to call this one point B. That's 0, 2. So we call that B. And the one that I can't see, we're going to call that C. Right? So when they ask you, what is the slope of a line? It doesn't matter which point you choose, as long as you choose 2 points to measure. You can try to measure the distance between this point and that point, or you can try to measure the distance between the furthest points. They're all going to give you the same value. Or you can choose the distance between these 2 points. Doesn't matter which one. If one person chooses the first and the other second, the other third, you'll all get the same answer because the slope will not change on any point of that line. It will stay the same. So if we did the rise over run method, and I chose the 2 easier points, and I did rise over run, that's using the graph. If I did rise over run, I'll count up 1, 2, 3 units up. That's my rise, +3, and 1 unit to the right. So that becomes 3 over 1. So my slope should be 3. That's choosing the 2 closest points. Let's say I chose the middle point and the far point, and I did rise over run again. Well, if I count up 1, 2, 3, 4, 5, 6. So that's going to be 6 over, and I count over 1, 2. And what does 6 over 2 give me? 3 as well.
3.
And then let's say I'm like, I choose the furthest points away. So this one and this one. And I count those, and I do rise over 1 again. I count 1, 2, 3. Hold on, I missed one. I count 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I count over 1, 2, 3. What's 9 divided by 3 give me?
3.
3 as well. And so for no matter what points I choose on the line, they even skipped a point here. If I chose this point here, and you're normally looking for the corners where they intersect whole numbers, try not to choose decimal numbers unless they make you do it. But if I chose that point, you would see that no matter where I count it from there, I will get the same slope. Some of you may remember the connection here. Do you guys remember when we were doing linear sequences? If you remember the linear sequences, we had like -4, and then here that's -1, and then 2, and then
Yes, yes.
what was that, 5, right? That's the actual output values. And if you notice, they're going up by 3s. That is the connection. When we were finding those differences between the tables, is the exact same thing as the slope of a line. Remember I said the table and the chart go together. One is what we call tabular. The other one is what we call graphical, but they still represent the same information. And so that's the slope of the line. And if you remember, we were able to take that as 3x. So that's what we're breaking down to. We're going to finish that on Thursday. But for this one, the answer there would have been A. And we have 1 minute. If you have to go, I totally understand, but I just want to show you how you could do that. And that's my alarms going off. All right. Just to show you with the formula, if you had used the formula, let's say you did not see a graph, and you said y2 subtract y1 over x2 subtract x1, you could choose any of these. I'm going to just choose these two because they're right in front of me. I'll choose the bigger x value, positive 2, subtract the smaller y value, which was negative 4. I'll choose the smaller x value, which is 0, and subtract the smaller x value, which is negative 2. Those two negative values in there are going to turn to positive, so that'll become 2 plus 4, and 0 plus 2. I'm going to write up here so you can see it clearer. 2 plus 4 is 6 on the top. 0 plus 2 is 2, and the 6 divided by the 2 gives me 3, and I get the same answer if I did it algebraically. And basically what math does, it brings together what I can do algebraically, what I can do inside of a table, and what I can do graphically. And then the last thing is geometrically. We can 4 ways we can represent the mathematical world that we encounter every single day. And that's why you see it split up in that units that we have, because they all can be represented differently. And we can use that to make our life easier, more luxurious. And that's why we are like one of the most luxurious ages in Earth's history. We have phones and all sorts of stuff to make our lives easy, heated water, because of our mathematics and science skills. All right, so here we go. That's where we're going to pick up on Thursday. I know it's a lot of information, and so hopefully that pushes you to review everything that we've done. So I should have a few questions come Thursday. Remember, we already said to you, you want to start at page 102 to 105, but you do want to include what we just done here. So you're going to go a little bit past 105 to possibly about 107. So about 102 to 107. If you're feeling hungry for mathematics, you can go on to page 109. So you can push yourself if that's your decision. All right. And hopefully your mind's like, yeah, let's get this. I'm ready. All right. So I'll see you guys on Thursday. Stay positive. Keep practicing. And show somebody how to do what you learned.
All right, thank you.
Good night.
You're welcome. Enjoy your
Bye,
evenings.
guys.
All right. Bye-bye.
Bye, everybody.
Mr. Ray,
Yes.
so question, after the 10th, are we still going to be able to see the videos?
Yeah, I'm going to leave them up. So if you have the link, you can still go up there. I'm about to upload a few more tonight, so you should see them pop up.
And I had another question. Hopefully it's not too Nativia, did she already did her test on online?
I'm assuming yes, because she said
Okay.
when she signed up. I'm assuming then she didn't pass it. You know, I didn't really think about it until you just said that, but because she did say when I took the test, they had the video on, they made me do all that. So either she took it for a different subject, like language arts, or I think it was language arts, because she texted me saying she passed language arts.
Okay.
Yeah, so she took it online because she didn't want to wait, you know, with all the COVID-19 restrictions. You know, there used to be like, what, 30 people in the room. Now it's like 5 or something. So there's only like small amounts of people that can attend each time. So she was like, I want to get it done. So she took it online when she found out she could do it.
Thank you, Mr. Ray.
You're welcome. Enjoy your night with your family. See you guys Thursday.
Thank you. See you Thursday.
Bye.
All right. Okay, George.
Thank you. We need to
No
meet on Thursday. Yeah.
Yes, see you Thursday. Be safe.